Get ready for this. Scientists have just figured out how to simulate the very first moments of our universe on a computer. And no, this isn't just about building faster gadgets. We're talking about unlocking what could be the literal code of creation itself. This whole breakthrough is really trying to answer one of the biggest, most fundamental questions out there. The laws of physics, as we understand them, are all about balance, about symmetry. So, why are we here? Why is there, anything, instead of just an empty void?
Okay, so here's the deal. For every particle of matter, the stuff that makes up everything, there's this mirror image twin called an antiparticle. The Big Bang should have cooked up equal amounts of both. But here's the catch. When matter and antimatter touch, they annihilate each other. Poof, gone, just a flash of energy. So logically, our universe should be, empty, a total void. But obviously it's not. We're here. So something tipped the cosmic scales in favor of matter, and figuring out what that something was, that is the mystery.
To tackle a question that massive, you're going to need a whole new kind of computer. Seriously, the math behind the universe's first moments is so ridiculously complex that even our biggest, baddest supercomputers just can't. But now, a totally new way of computing is changing the entire game.
So what's the big difference? Well, a regular computer bit is basically a light switch. It's either on, a 1, or it's off, a 0. Simple. But a quantum bit, or a qubit, is on a whole other level. It can be on, it can be off, or it can be both at the exact same time. And that means it can explore a mind-boggling number of possibilities all at once. Right. This crazy property is called superposition, and it is the absolute secret sauce of quantum computing. Instead of a normal computer trying one path, then another, a quantum computer explores every single possible path simultaneously. And that's exactly the kind of power you need if you want to simulate something as wild as the creation of the universe. And listen, this isn't just a sci-fi theory anymore. A couple of massive, recent breakthroughs have officially moved quantum computing out of the lab and into the real world, giving us an incredible new tool to solve these epic problems. So here's how it happened. First, IBM built these amazing quantum circuits with over 100 qubits. You can think of it like a tiny, tiny particle accelerator right on a chip. It lets scientists perfectly control the starting conditions of a particle smash-up. Then Google jumped in with a totally revolutionary new algorithm. They call it the quantum echoes algorithm. Here's a cool way to think about it. Imagine you shout into a canyon. You send out your voice, it bounces all over the place, and a moment later you hear a clear echo come back. This algorithm does something kind of similar, but with quantum information. It sends a signal into the system, lets it do its thing, and then it listens for that perfect echo. That echo filters out all the background noise and gives you an unbelievably clear picture of what happened. So, how much faster are we talking about here? For these specific, mind-bendingly complex simulations, this new method is, get this, 13,000 times faster than the most powerful supercomputers on the planet. I mean, that's not just an improvement, that's a complete game changer. It's a true quantum leap, literally. All right, so a super-fast computer simulated the Big Bang. Cool, but what does that actually mean for us, for you and me? Well, this isn't just some abstract science experiment. This one breakthrough has at least 3 world-changing implications that could affect everything. First, and this is the really big one, we might, for the first time ever, be able to understand how our own reality actually works. We could finally get an answer to that huge question we started with. Why are we even here? We can literally run the Big Bang over and over in a simulation to see exactly why matter won the cosmic tug-of-war against antimatter. And the source material for this explainer takes it a step further, suggesting something even more profound, that these simulations could reveal how our own thoughts and intentions might actually structure the physical world on a quantum level. Just let that sink in. Okay, the second major implication, medicine. Think of this technology as a new kind of microscope, but one that lets us peer into the tiny quantum world where diseases actually begin. We could use this quantum scope to watch in real time exactly how a disease like Alzheimer's messes with our brain cells at the molecular level. We could design and test brand new drugs inside a simulation before they're ever even made in a lab, potentially leading to cures for things that have felt incurable for decades. And finally, the third implication is a complete revolution in the stuff we build things with. We could be on the verge of designing materials from the atom up, creating things with properties that we've only ever dreamed of.
I'm talking about things like room temperature superconductors, which would mean a power grid with zero wasted energy, or batteries that last for weeks, not hours. By simulating how atoms can be put together, we can invent materials that make today's technology look like it belongs in a museum.
And this isn't some distant future fantasy. This is happening right now. There is a full-on global race to build practical, useful quantum computers, and it is pushing this technology forward at a dizzying speed.
The major players are exactly who you'd think. The US and China are pouring billions of dollars into this, and all the tech giants, Google, IBM, Microsoft, are locked in a fierce competition to get there first. This is the next great technological revolution, and it's happening before our eyes. And things are moving fast. We've got the algorithms, the software today. Over the next 2 to 3 years, the hardware is going to catch up. That means by 2030, we could see this technology having a real impact on our daily lives. That's practically right around the corner.
The source material for all this leaves us with a really powerful thought. It puts it like this, and I'm quoting here: "We're developing technology that operates on the same principles God used to create reality. Science isn't disproving faith, it's catching up." Wow. I mean, it's a pretty fascinating idea, right? This idea that science and spirituality might not be opposing forces, but might actually be heading to the same destination.
So, I'll leave you with this question to chew on. As we build these incredible quantum machines, are we just getting better at math and science? Or are we actually starting to learn the fundamental language of creation itself?